This is a screencast for section 10.2, example 4. We're going to model planar motion. Well, plane means coordinate plane, but we're actually talking about an airplane too. Finding ground speed and direction is what we're going to look at. Now remember, ground speed from pre-calc is the magnitude of the vector. A Boeing 727 airplane flying due east at 500 miles an hour in still air encounters a 70 mile an hour tailwind acting on the direction 60 degrees north of east. The airplane holds its compass heading due east, but because of the wind acquires a new ground speed and direction. What are they? Well, first of all, I'm going to call u the vector of the airplane without any wind whatsoever, and then v the vector of the wind. So you can see u is the airplane where it's supposed to be heading. V is the vector of the wind, so the wind's blowing the airplane up a little bit north, I guess. And then u plus v is the new path and magnitude of the airplane. So let's come up with vector form of these two vectors. U is going to be 500, 0. The x coordinate is 500, the y coordinate is 0. Now v is going to be based off of this vector, so I'm going to look at that a little bit off to the side in another triangle. This is a 60-degree angle off of the x-axis. My x-coordinate is along the x-axis, the y-coordinate would be here, and then 70 is the magnitude or speed of the wind. So now I can take this and some trig and get that the x-coordinate is 70 cosine of 60, and the y-coordinate is 70 sine of 60, which then simplifies to be 35, because cosine of 60 is 1/2, or 35 square root 3, because the sine of 60 is square root 3 over 2. Now I want to find the speed and direction. So let's look at speed first. Speed is the magnitude of this new vector, so I want to find the magnitude of u plus v, these two vectors combined. So I have to first add u plus v. U is the 500, 0. V is the 35, 35 square root 3. Which means then u plus v is 500 plus 35, or 535, and then comma 0 plus 35 square root 3, so 35 square root 3. The magnitude is the distance of, or length of, that vector, so it's going to be the square root of x squared plus y squared, or a squared plus b squared in vector form, and then I get about 538.4 miles an hour. Now that does make sense because the plane was originally flying 500 miles an hour. The wind is blowing a little bit in its direction, so it's going to be flying a little bit faster than that 500 miles an hour, which is 538.4 miles an hour. Now, as far as the new direction, that's going to be determined by, we'll call it theta, and theta is this new angle off of east. At least that's what I'm going to call it. And then, I could call it off of north, but that makes it more difficult. I'm going to say it's from the direction north of east. So therefore, I'm going to draw a little triangle. Here's theta, here's my vector u plus v. Drawing a perpendicular down to the x-axis, I have that my x-coordinate is 535, my y-coordinate is 35 square root 3, and I got that from the u plus v vector, so the x-coordinate and the y-coordinate, or a and b. So now, if I want to find theta, I'm just looking at the inverse tangent of the opposite over adjacent, 35 square root 3 over 535, which is 6.5 degrees. Now, we have to remember to clarify is that 6.5 degrees, they used north of east, but then the diagram has east of north. Just make sure you clarify. This is 6.5 degrees north of east, so it's not straight east, it's 6.5 degrees north of straight east. The now try problem number 25 also deals with navigation of an airplane. An airplane flying in the direction 20 degrees east of north at 325 miles an hour in still air encounters a 40 mile an hour tailwind acting in the direction 40 degrees west of north. Be careful, those are two different descriptions of where the degrees are based off of. The airplane maintains its compass heading, but because of the wind acquires a new ground speed and direction. What are they? Alright, well, first Let's call u the vector of the airplane without the wind. Now, according to our problem here, that is a vector with magnitude 325 miles an hour, and 70 degrees, they called it, well, 20 degrees east of north. I like basing my angles off of east, so it's 70 degrees north of east. V will equal the vector of the wind. The vector of the wind is 40 degrees west of north, so that's going to be over here in quadrant 2, which means it's 130 degrees of rotation from the positive x-axis. Again, I'm using my angles off the positive x-axis, so that's just easier to work with. Now the plane is going to be traveling at the vector u plus v. It's going to take account both its original path and now the wind. So we're going to take at the end of vector u here, we're going to add on vector v, which I know is not completely parallel, but it's supposed to be. And then we have vector u plus v, the new path and magnitude of the airplane. So first let's figure out what vector u is in order to get this u plus v vector. The reference triangle based off of u would look like this. The reference triangle based off of vector v, the wind, would look like this. Which means vector u is going to have the x-coordinate, or a value, 325 cosine of 70 degrees, and then the y value, 325 sine of 70 degrees, which is about, well, this. Now vector v, again, we're solving for the x and y coordinates, or a and b values, using trig. So that would be 40 cosine of 130. The cosine is adjacent over hypotenuse. Solve for the adjacent. Then 40 sine of 130. So the y coordinate, sine of 130, would be opposite over hypotenuse. Solve for y. Now that we have both u and v, we can find the magnitude of u and v, or u plus v. Now u plus v is going to be the u vector plus the v vector. Lots of messy decimals. This is always going to be an approximation then. You should be using the exact values in your calculator, of course. Then we're going to take the square root of the x value plus the y value, or a value squared, plus the b value squared, and we get 346.735 miles an hour. And that does make sense because, again, the vector is going somewhat in the direction of the original path of the airplane. So we are going to be increasing the magnitude of the vector when we add u plus v. In other words, the speed is going to be faster, 346 as opposed to 325. Now, theta, the new direction of the airplane, that's going to be based off of the vector u plus v. Theta down here we don't know, we're trying to solve for, but we do know that the a value of u plus v is 336.042. That's what we found when we added the u and v's y coordinates. The x coordinate then is going to be 85.445, what we found by adding the x coordinates of u and v. So then to find theta, we can just take the inverse tangent of the opposite over adjacent, and we get about 75.734 degrees. Again, very important that you state where this is based off of. Is it 75.734 degrees east of north, west of north, whatever? Well, we based it off of the east axis, so it's going to be north of east.